This conference will now be recorded.
Hello friends, welcome to the demo session on data science. I hope we have got good numbers right now. We will start the session. So before starting the session, I like to give a few nice to have things. So if you have any questions during the session, I would request that you can use the chat window. So there is a chat window available. You can post your questions there so that it would not break the flow of the session. And in the end of the session, I'll be giving like 10-15 minutes of Q&A time so that if you have any questions directly, you could ask at that time. But during the session, in the middle, if you have any questions, I would request that you could put that in the chat window so that I will be able to look at the chat and I can ask, I can respond to your questions. All right. And maintain the decorum of the class so that it won't be disturbing for other people. And today's topic would be to understand the practical overview of data science. We would be understanding it from a industry perspective, like what are the key components of data science, how they are related, and what we are going to cover in the course and why it is important. So these are all the topics we will be discussing today. I'll be focusing on some of the important questions which people will be asking so that those will be clarified by the end of the course. And so that's the topic for today. Generally, I'll be doing this session on a notebook. So let me open up a notebook. Create a new notebook for you. Mostly it will be like a blue screen like this. And all our sessions will be kind of written sessions where we'll be writing some notes on an extempore basis. I will be taking the class like this. So it will be replicating a real world blackboard scenario. So today's topic would be practical understanding of data science. Practical understanding of data science. So we'll go through the start till end and understand how data science has evolved and what are the key components of it, what are required for learning and so on. Before I start, let me introduce myself. I am Sitaram and I have around 15 years, over 15 years of experience in IT, and out of which around 8 to 9 years I'm working in the data area itself. Prior to this, I was working as a big data architect, have good experience in big data and other things. But for the past 3 years, 3 to 3.5 years, I have navigated towards data science area. So I'm working as a senior data scientist for a MNC company, and I work with multiple algorithms. We have different algorithms which are used. I especially work for insurance domain, but I already have good expertise in retail and banking domains as well. Coming to my educational background, I have an MTech from BITS Pilani, India, and I'm currently pursuing my PhD from IIIT Hyderabad. And my specialization is in deep learning, computer vision, and so on. So it's like a dual benefit for me for doing the sessions. I have a full-time job, but I also do sessions as a part-time gig. uh, One kind of benefit which I get is like, I am in constant touch with the subject. I know like what things are happening, what are the newer technology things which are changing, so that I'm in constant touch with the subject. That is uh, my kind of win-win situation. And for the students, for the participants, whoever will be in the course, they will also get like a clear understanding of what is happening both in the industry and as well as in the academia. So I'll try to blend both these worlds, because either if you see that people will be doing courses from academia, there will be too much of research oriented, too much of theoretical, derivations and other things, which are not really used in the industry world. And if you see a course from an industry perspective, they're pretty much high level, saying that just use this library, you get the result, and so on, but not giving the insights about why to use a specific library, when to use a specific library, and to what data sets a specific application has to be used, and so on. So there are a lot of these nuances which need to be understood as a data scientist when we work for a company, and we need to be very careful to pick and choose the right set of algorithms, right set of analytical work, right set of math related work, and so on. So I will be helping that, to bridge that gap. So that is where I come from. You will know about me a little bit more while we are doing the course. So let me not waste my time further, and I will definitely know about you during the course. As and when we interact more, I'll be knowing more about you, like what you do, what is the intent of having a class, and so on. So that we will take it forward. Let me start the demo today. So I would like to talk about the initial phases of this data analysis. What happened in the initial phases of the data analysis? So imagine you are working for a retail company. You're working for a retail company. A retail company, like these are like the Walmarts or the D-Marts or Reliance Fresh or whatever. These are the companies which are kind of selling products. Now, those could be groceries or clothing or anything. They are selling the products, and they need to keep track of the products what were sold, right? So today a cashier is kind of billing certain products. He or she need to keep track of how many products are sold, what are the values of the products, how many customers purchased it, and to keep track of all these transactions. Typically these retail companies, what they have done is they have to do some kind of storage solutions. The primary storage solutions which were used since 1970 are called as RDBMS databases. These are RDBMS, relational database management systems, typically using some kind of SQL kind of a language, and we use SQL queries to access these RDBMS databases. Typically for storages, like, for example, I go to a grocery store and I want to purchase certain things, maybe like 1 kg of sugar, 5 kgs of rice, and 1 kg of salt or something I'm purchasing. I would like to store all these purchase information in a table. The reason is because tomorrow I need to understand how many kgs of rice are sold or how many kgs of sugar are sold. So if I want to get this kind of information, I'll be able to quickly query the table, RDBMS table. These RDBMS tables will be Oracle or MySQL or SQL Server, PostgreSQL, or any kind of tables, and I'll be able to query these tables to get the answer. So for the last month, how many kgs of sugar is sold, so that I can talk to the suppliers to deliver the same amount or even more in the next month. So typically these tables are called as ODS, operational data stores in a real world sense. Operational data stores which are holding the operational data of your business. Now I took an example of retail, but you can change this to banking, manufacturing, insurance, or any other business area, but the same thing will be happening. Now, when people wanted like the understanding of what has already happened, which is typically called as descriptive analytics, so people want to run these SQL queries on the tables. Now, for example, I want to know in the last month how many kgs of rice were sold or how many kgs of sugar is sold. Now, now for that, I need to run some SQL queries. SQL is a language in which we can interact with these relational databases, and you will be able to extract information. You can also insert, update, a lot of things are there, but we will be able to extract the information. Here, the purpose is extracting of the information or probably writing certain information to the same table. Now, what is happening is these SQL queries used to run during the business hours. Just imagine that the business hours are 9 to 5. So 9 to 5, the business will be open. So while the business is happening, if you're at the simultaneously, if you're running the SQL queries, at certain points, there will be some kind of delay or lag in the actual transactions. So there will be some kind of SLAs. The actual system has to perform or respond in some within few seconds or so on. Generally, it will be 3 seconds. So if it is not performing well within the 3 seconds mark, then it is breaking the SLA loss. And then why that is happening is because there are high. I request everyone to go on mute, please. Please check your. Not sure. Please, everybody, check your mute buttons. Ensure that you are on mute. Not able to mute the person. Lakshmi Garu, if you can mute, that will be great. Okay. All right. So what we are saying is the 9 to 5 business, regular business is happening from 9 to 5. And at the same time, if I'm also running high-end SQL queries, that is kind of having problems with your front-end transactions. Now, the reason I'm running SQL queries is to understand the analytical, analytics of your data. Right? I want to understand how many customers are there, how many, how many products are sold, which are the high-selling products, which are the low-selling products, so that I can plan my demand and supply. But for doing that, I have to run the queries, but I can't run the queries in the daytime, 9 to 5, because my regular business is running. Because of that, people said that, okay, let us not run the queries during the daytime. Let us create something called as the nightly jobs. So if you see, most of the data analytical work happens during the night time. So the businesses work from 9 to 5, and the later point of the day, maybe 8 o'clock, 9 o'clock, 1 o'clock in the night, 2 o'clock in the night, these jobs run. And these jobs are nothing but the SQL jobs or combination of the jobs. Generally, transformations, take the data, transform it, update it into some other table. So such kind of jobs, and they will be running in the night. Now, this worked for many years, and the mainframe systems and regular SQL systems, they all worked very well for many years, till the time that there was an influx in the internet and in the geographical expansion. So with the internet and the other one is geographical expansion, geo expansion. What happened is there was no such lean period that the business only runs from 9 to 5 because of the internet. Now the websites were created, the businesses went online. They were no longer confined to the shops. They are now online, so people can buy at any time. And there was no such business period that 9 to 5 is where my business happened, and after that it will be a off business period. So there was no such kind of lean time. And also the geographical expansion. In the olden days, the shops used to be in one geography. Say like these are the companies from US, so they were primarily concentrating on US. But because of the geographical expansion, they have opened the centers in Australia, they have opened the centers in Dubai, or maybe Singapore, or any part of the Europe, and so on. So what is happening is there was no such lean period in sense, the period in which I can say that this is the time where no geography is active and I can run my jobs. You got it? So that problem came into picture because of the advancement in internet and advancement in the geographical expansion and so on. But then came that people started something called a data warehousing, and this happened close to 20 years from now, to 20 years before. So around 2000s or so, this actually happened. 2000 to 2010 is the time zone in which this entire stuff happened, where people started doing something called as data warehousing. Now, data warehousing, I can create a table again. DWH. Now, data warehousing is a system like where we are trying to decouple the front-end tables to the warehousing tables. Now, we are trying to say that let us dump this data into another table, and the dumping time is very minimal, and we try to find out a small lean window where this dumping can quickly happen, or which is impacting a geography which is not so important, right? So even if it is impacting, it will be impacting a geography which is not so important. So that lean period regularly around 1 to 2 a.m. in the US time, that is the time this kind of dumping happens. And when the dumping happens into the data warehousing tables, the data warehousing tables are kind of a replicas of your operational data stores. And apart from just being replicas, they have great advantage. The advantage is that they can store historical data. For example, I can store 1 year back data, I can store 5 years back data, I can store even 10 years back data, and I will be able to do the comparative analysis, like what happened 10 years back, what happened 5 years back, and what happened 1 year back. And what is the, for example, I wanted to identify the impact of COVID over last 2 years and the impact on the sales month by month. Such kind of analysis I want to do. Then I will be able to perform such kind of analysis provided if I have this data stored in a historical table. Data warehousing are the solutions which basically provide this ability, and great important thing is that they are decoupling from the actual tables. So I can run my queries 24/7 without impacting the front end data or front end transactions, because my tables are completely decoupled from the original tables, and I will be able to run the data. So far, so good. Are you guys following? I want to just get a yes from you. You can use the chat window and let me know if you are following. Yes? Okay, great. Thank you. So what happened is people started creating data warehouses, but these data warehouses were primarily focused on structured data. Now, what do I mean by structured data? The data which is stored in rows and columns. Most of the data, whatever business data, is structured in nature. Almost like 80% of the business data is structured in nature, primarily stored in tables, primarily using files and other kind of formats, mostly in the structured data. So data warehouses are primarily focused in structured data, and they will be able to do some calculations or analysis on the data and can produce some reports or graphs and charts. So that is the primary purpose of the data warehousing system. But as the world has grown and the systems have evolved, people are also having different varieties of data which is coming into picture. So those different varieties of data, if I want to store unstructured data, then people started creating something called as data lakes. Data lakes. So data lakes are nothing but the unstructured storages. Initially, we used something called as Hadoop systems, and recently, for the past 2-3 years, we are using cloud-based data lakes like AWS or Azure and so on. So these are the different data lakes we are using, which are helping us to not just store the structured data, but also store unstructured data. What could be unstructured data? Imagine, there could be an image. I'm just drawing a mountain and a river and so on. So these are images. I can store images. I can store some videos. Right? I can store images. I can store some videos. I can store some logs. Logs data. Logs can be something like system logs, transaction logs. It can be operational logs. So you can store logs data. You can also store some sensor information, some IoT sensors or whatever. You can have some sensor data. Some sensor information can be stored. And what else? Like we can store some textual information. So I can have text data. Textual data could be as documents or comments or it's not audible. Am I not audible to you guys? There is a comment. Am I audible to you? Clear and crisp? All right. Okay. Maybe with some, maybe Yamini Kanakadurga, I think she's having some issues. Okay. If it's not audible, what I would recommend is log off and log back again. And please check your headsets or whatever sound system. Right? I request you to log off and log back again. All right. So let us continue. So what we are understanding here is so people have created something called as data lakes, which are now capable of storing huge volumes of other data. We have images, we have videos, we have log files, we have sensor data, textual data, everything else. We have all this data, and now we are creating one-stop storage where we can store all this huge volume of data at one place. That is what is called as a data lake. In recent days, we are using AWS, Azure, cloud-based data lakes. There are different names to it, but we are primarily using them for storages of both structured and unstructured data for our analysis. Now, this is not a simple work. You have a lot of coordination required, lot of technology expertise required, and so on. So the people who will be working in this particular area This area is called as data engineering. You might have heard about data engineer. This area is called as data engineering. Big data, Hadoop, Spark, and similar kind of other systems are there, which will be helping us to do the data engineering. Data engineering involves in data ingestion. As you're seeing, there are different sources from which the data has to be ingested. So you would need to collaborate with multiple tools. Maybe it could be like an FTP based ingestion, or it could be based on log ingestion in a streaming fashion. You might be using Kafka, or you might be using something like Kinesis. There could be IoT related sensor data. There could be a table which you're dumping up. You could use something like Scoop or Flume, or other kind of tools are there which will help us to push this data to a centralized storage. So once you have the data at a centralized storage, the next step is that you try to try to analyze what this data is. This data is in a raw format, right? Pretty much a raw format, and most of the data, if it is in a raw format, you will not be able to extract full information from that raw data. You have to do something called as transformation or pre-processing of your raw data, so that you can make the raw data in a consumable format. So for that, you generally do something called as exploratory data analysis. Exploratory data analysis. So exploratory data analysis is nothing but it is helping us to convert this raw data into a consumable format. Raw data into a consumable format, where you're basically doing some kind of transformation. You are doing something like, some pre-processing techniques are there, right? We are also having something like encoding. We have something like scaling techniques. We have normalization. We have something missing value treatment. Missing values imputation, we call it as TION. Missing value imputation and so on. So don't get bogged up with all these words. Just understand that when I have my raw data, which is ingested into data lakes, now I can't use the raw data for my analysis. Now I have to kind of combine multiple tables, multiple data points, add some data points, remove some data points, try to clean up the data so that it is in the consumable format. If you have garbage in your input, if you give the garbage to your models, the models will give you garbage results. So garbage in, garbage out. So you don't want to give garbage to your models. You have to do something called as data cleaning. You call it as data munging. You call it as data transformation. Different names are there. But what we are intended to do is we try to clean the data so that my data will become clean and it is in a consumable format. So output of your exploratory data analysis is trying to identify what are the important features, what are the important variables which are contributing for my analysis, and keeping only those ones, removing unwanted ones, and making them clean so that the clean data will be used for my analysis. So that is the next step, where we try to do something called as modeling. Modeling is nothing but you are applying the required algorithms. There are a whole lot of suite of algorithms which are applied, and mostly, unfortunately, in data science, people only concentrate on the modeling part. People only concentrate saying that, what algorithm to use, which one to use, which is giving best accuracy, what are those. So this is the area which is of prime focus. There are great suite of algorithms, for example, are divided into supervised. We have within the supervised, we have classification and regression algorithms. Again, in classification, there are again 10 to 12 algorithms. In regression, we have 7 to 8 algorithms and so on. So supervised are one set of algorithms. We have unsupervised. We have reinforcement learning. So unsupervised, again, we have something like k-means clustering, we have hierarchical clustering, we have market basket analysis, principal component analysis, like that. We have a lot of them. So I am not kind of putting all the algorithm names, but for now, just understand that there are different types of algorithms which are subdivided as supervised, unsupervised, reinforcement learning, and so on, which will help us to do the predictions. And what we are doing right now here is, when the data is provided, using the data, we are trying to apply some of these algorithms and try to make sense of the data. We are trying to do futuristic predictions by applying these algorithms. Now, this is not a one-time procedure. So you might have to do something like iterations. This is an iterative procedure. So you start with one algorithm, you see that it is not performing well, then you change some of the parameters of that, then you further add more data. So this goes in multiple iterations, and it is called as hyperparameter tuning. Hyperparameter tuning. So hyperparameter tuning is a technique in which you're trying to optimize these algorithms so that they perform to the best, and then we get the best results. So what is happening, once our data is there, we clean it, and cleaned data will be provided to the algorithms. Algorithms will try to change some of the hyperparameters so that they get best tuned, and then you finally get the final model. Now, what is a model? Model is an outcome of this algorithm, and it is nothing but, you can think it like an executable which will have the relation between input and output, and it has all the clues of doing the predictions in the future. Imagine I am trying to predict, maybe for a bank, I'm trying to predict who will be the customers who will be eligible for giving a loan. Okay, there are a lot of customers who are applying for the loan, and I want to use an algorithm in which I need to understand like who will be the customers who will be eligible for giving the loan, right? So so I can say like, okay, there could be a lot of parameters which are helping me for predicting the loan. Maybe what is the salary of the customer, what is the bank balance, what is the spending patterns of the customer, and so on. So all these important features will help them to predict what will be the loan eligibility for the customer, whether the person is eligible or not eligible, maybe pending with the bank, or there could be different kind of statuses based on which we are trying to predict. So by passing this data and using these algorithms, we are trying to do something called as hyperparameter tuning, and then finally we are constructing the model. Model is like an executable which is having all this information extracted in some kind of a function. And the function, when we pass a new data, it will be able to predict whether the person is eligible for the loan or not eligible for the loan. So what we generally do is, so most of the courses we see that they will stop here. They will say like, okay, we are using some XYZ algorithm, we are getting some 90% accuracy, then we are done. That is not done, that is just half done. What we need to know is, how do we really deploy these models into cloud? For example, I'm taking an AWS cloud, say AWS cloud. Now, how do I deploy these models onto an AWS cloud? And how do I create maybe like an executable? Let me take a color, like let me take an orange color for. So I create, this is a model, I create an API on the model. So what will the API do? It is kind of an it can be acting as like a endpoint for my customers to call this endpoint and then get the result. Okay, so maybe I can create an app with I can create an app where I will be able to create a website, maybe website for a bank. Say that ICICI Bank is creating a website where it takes the customer name, where it takes customer salary and age and other things, and then it will have like a submit button. Once the button is submitted, then you will be calling the API. You'll be calling the API with all the parameters. So the bank will collect all the information. What is the name, age, salary, bank balance, marital status, number of kids, and liabilities and other things. And then it will be calling the API. And then API will return based on the given parameters. It will return an answer whether the person is eligible for the loan or not. Maybe there could be another further prediction that if a person is eligible, what is the loan amount he or she is eligible? So, are you eligible for 2,50,000, 8,42,000, 5,16,000, whatever, right? So once this submit button is done, then it brings all the parameters through the endpoint API call, and it invokes the data, it gets the output, and then it returns back the information, and you would show a second screen saying that congratulations Sitaram, you're eligible for 5,25,000, right? And this entire applications could be written in say like Angular or React. These are your React React or any other kind of front end systems, right? It could also be a mobile application, so it doesn't need to be a website. But these are the consumers of your API. They will be calling from a website or a mobile application, or maybe like from a voice operated system like Alexa or something like that. So they will be doing the calling, and they will be getting the results as an output. This type of interaction is called as real-time inference. Real-time inference. Now, for doing real-time inference, now I might need to do something like Dockerization. So you'd be using Docker, you'd be using Flask. A lot of things are there which will help you to deploy this model as as a Docker container, and that could be invoked using the API, and so other systems will be invoking the API to get the results. Now, this is the real-time inference. You can also do similarly in a batch inference mode. Now you can also do batch inference. Now, what is a batch inference? You might be running a scheduled job using Jenkins, or you have some kind of pipeline being built. Multiple cloud solutions have different pipelines. But to generalize, you could use something like Jenkins or so on to schedule the job at an equal interval of time, right? And then what you do is you can invoke the same API. You can have the same API invoked. But now this API is not invoked in a real-time mode, but it is invoked in a batch mode. So what you might have is you might have some input files. So you have an input file. You'll be calling this input file in a batch mode. The input file can be created by the agent or the bank person. he or she might give like 100 customer applications in a flat file, and that file will be invoked by the API. It will take every record at a time. For every record, it will be predicting whether the customer is eligible or not. So this might have like say 100 customer applicants for in the last 1 week, and then we are trying to predict on a Sunday. You run a Jenkins job and then try to predict like who of them who are eligible and who are not eligible. Then we might create an output file with the eligibility and ineligibility list. If a person is eligible, we will also predict like what will be the probable loan amount to the person as well. Okay, so this is how it works. So here we are seeing that we have the batch inference. You can have input file, you can have output file. Right, so input files and output files, they will be interacting. Input files, this is entire is in the batch mode, and we might be running maybe a Jenkins job every weekend on Sunday 9 a.m. in the morning. This job runs. Take the input file. This input file might have 100 records. It will take one record at a time, and every record will be having the information about the customer who has applied for the loan. It will be having the bank balance, the salary, age, and other kind of details. And for that, it will predict whether the person is eligible or not. And that output will be captured. So for every input, you will be capturing the output. That will be also created as a file. And these two files will also be available in the data lake. I can't link the entire line, it will mess this up, but just imagine that these are also available in the data lake. So you will put the data into the data lake, batch will pick the file from the data lake, and then once the batch is completed, it will create another file in the data lake. One more last thing which we need to understand from a data science parlance is the ability to do visualizations. So that data science is all about telling stories of our data. So what is the data portraying, or what is it telling us, what is the insights it is providing, that can be provided using data visualizations. Data visualizations we could do using some of the third-party softwares like Tableau or Power BI, likewise. Or we can also use some homegrown tools like Seaborn or Matplotlib and so on. So the data visualizations help us to visualize entire data. So you don't want to give your output as a Excel sheet, right? So you don't want to give your output as an Excel sheet. You want to provide some kind of visual analysis of your output. You want to say like, out of the 100 people who have applied, 52 people are approved. Out of the 52 people, 16 people are approved with a home loan of say more than 20 lakhs. So like that, you have to give some kind of visually intuitive outcomes rather than giving a one full huge Excel sheet at which people might not be able to understand. And by providing these visual appearances, we will be able to extract the analysis as a story. We are able to tell a story saying that this is how the data is, these are the insights of the data and all that stuff. And further doing that, you might have to have a little bit of understanding of Tableau or Power BI or Seaborn, Matplotlib. We will be learning about Seaborn, Matplotlib, and a little bit of Tableau and Power BI. But the intent here is to have a little bit of understanding there. Now you might have a question that Sitaram, you have filled up the entire screen and there's a lot of thing to take. Which areas need to be concentrated, what are the important ones, what are the not important ones, and so on, right? So if you're working for a startup or you're looking for a product company, small product company again, then you might need to become a full stack data scientist. A full stack data scientist is somebody who is familiar about how do we do data ingestions, what are the storages, storage patterns, different types of exploratory data analysis to be done, different algorithms to be experimented, how do we do model deployment. So this entire piece is called as uh, MLOps. MLOps is like machine learning operations. So you need to be familiar with MLOps related concepts, like how do we deploy as containers and Dockers and so on. How do we create these pipelines so that entire this training process is automated, so that you don't have to wake up in the night and then start a job and sleep, right? You don't have to do that. There is an automated procedure which is kept so that the entire job run in a trained fashion, right? This is how it will be used, and you have to also interact with front-end systems. You might have to create APIs and other things which will be interacting with your front-end systems, and you will be also be dealing with the batch inferences and some kind of visualizations. A full stack data engineer, data scientist will be doing all these things, provided you are opting for a small startup or maybe like a small product company. But if you are looking for a bigger service company or maybe a bigger product company, there will be clear cut roles, right? For example, a service company might be billing the customer with different roles. There will be a role called as data engineer. There will be a role called as cloud developer, right? Who will be responsible for setting up the cloud, ensuring and all the connectivity, storages, and so on. There will be a person called as data scientist. So here, this is the area which is the data science area. Data science, this is the data engineering area, right? This is the data science area, and there will be a job role called as junior data scientist, senior data scientist. There will be a job role called as ML engineer. ML engineer is the person who will be responsible for deploying these models into cloud. He will be responsible for interacting with other front-end consumers, maybe websites or mobile apps or whatever, and creating all these APIs and containers, and scheduling these jobs using Jenkins or any other kind of pipelines. See, all that work will be done by an ML engineer. There will be a separate person who will be a data visualization expert, who will be primarily maybe a Tableau developer or a Power BI developer, who will be able to extract the data and can create some dashboards which will be able to show the visualizations, right? So depending upon which type of job role you're opting for. So you're opting for a small startup or opting for a small product company or a small company, then you might have to cover the entire breadth. That is how the learning also happens. If you have a full-fledged understanding of all these concepts, you have a great understanding. But if you are you're opting for a company which is a good service company, like service companies also will have different roles because they can build different roles, or you are opting for a good product company which is well settled and there will be clear cut roles. There will be another question that, Sitaram, I am a database admin, I am a DBA, which part of this entire journey is suitable for me? So there are different entry points for different people. For example, a person is a database administrator, maybe a Oracle DBA or something like that in the past, has good understanding of SQL queries and other things, then an entry point here would be easier. So a data warehousing systems, doing data ingestions, running queries, doing data transformations, all those things, this area is a very good entry point for somebody who is already having some data experience, right? Most of these data areas are, they will be able to clearly understand that, right? And if you are maybe like somebody will ask like, Sitaram, I'm a front-end developer, but I would like to come into this data science area. I would like to learn that, or maybe I am a QA developer, QA tester, who's primarily working on manual testing or some kind of automation testing on front end using Selenium and Java and other things, then what should be my entry point? For that, the entry point is this one, which is called as ML engineer. The job role is called as ML engineer, who will be interacting with front-end systems, will be creating APIs, invocation points, knowing a little bit of Docker and Flask for creating the end-to-end applications, maybe doing a little bit of batch inference and other things. So ML engineer will be a best role for somebody who is having such kind of experience in the past, like maybe like a front-end developer, Java developer, .NET developer, or maybe like an architect or QA, especially into automation, Selenium, and other kind of things. This will be the entry point, and slowly you will be ingesting into the central area. You can say, like, if I am having good experience in coding, development, and other things, what will be my entry point? Then you can try it as a junior data scientist, where you will be doing a lot of programming, where you will be writing some codes for creating models and data analysis and other things. That will be helpful for you. The data visualization experts can quickly penetrate through this area. They might be doing independent data visualization products, but slowly they can ingest here, have some learning on the modeling, and then can become like a full stack data scientist. So these are the different areas which we need to be concentrating, and this gives a full-fledged understanding of how these end-to-end operations would work. Let me quickly do a summarization, and I will open up for a few questions. I would also talk about what will be the different areas which will be covered in the projects. That I will talk a little bit, but for now, I'll quickly summarize. So we started with understanding a retail data, and we saw that data is stored in RDBMSs, and SQL queries are performed to get the analysis of the data. But because they are having problems, we run nightly jobs. But the nightly jobs also came into problems because of the internet and geo expansion. So we created data warehousing systems, and data warehousing systems are primarily limited to structured data, so that to store unstructured information like images, videos, logs, sensors, text data, and so on, we have created something called as data lakes, which are kind of storages for all the data. So once the data is stored, the next thing is to analyze the data. So before analyzing the data, we will be doing some kind of transformation, pre-processing, encoding, scaling, so that we can clean this data, which will be provided to the models. Once the clean data is provided to the models, they will apply a whole suite of algorithms which are suited for the type of data and type of outcome we were expecting. And then based on that, they will be creating models. Now, these models are the executables. Those can be stored on some cloud solutions, AWS or Azure and so on, and we can create APIs on the models. So the APIs will have endpoints, and they can be consumed by front-end systems like websites or mobile apps and so on, and they will be providing the input data, and then they will be getting the output results. Similarly, we can also do batch-based inferences, where the APIs can be consumed in a batch mode, which is scheduled on some weekly run or a daily run or a monthly run, and they will take some input data, run the algorithm, and then produce some output results. Similarly, we can also do data visualizations, which we can take these outputs and show them in a much more visualized manner, so that people can understand. Picture speaks more than 1,000 words, so that you show something in a pictorial manner, that will be much more effective, rather than giving them some Excel sheet with 1,000 rows, which people can't understand, right? So that's how this entire data science thing will be working. Okay, so just to give a one small brief about what we will be doing in the course. So the course will be around 2 to 2.5 months. I can say like 10 to 12 weeks, give and take. We'll have, this is the timeline we are looking for. So during the course, we would be having 20 plus projects. So I intend to do a project-oriented learning. I mostly don't have a lot of presentations, one or two max. So most of the course throughout will be going with the projects itself. So we'll be doing projects, code oriented thing, and some extempore sessions like this. So they'll be very, very dynamic. You might be asking questions, and I will be explaining about them. So it will be like very dynamic session, not like a presentation which I'm presenting and then I'm only going through those points. That is not like a session which I would like to do. So these 20 plus projects will be mini projects which will be along with the algorithms, whatever we'll be learning. So we'll be knowing like how to do end-to-end programming for these projects. And these projects are from different industry verticals. They are from healthcare, retail, banking, manufacturing, and so on. So there are a lot of industry verticals we are taking, and primary ones we are concentrating so that we get a clear cut understanding. We would also do capstone projects, at least 2+ capstone projects, which are like full end-to-end projects of deploying them into cloud and seeing like how to create Docker containers using the DevOps and other things. Those all things will be discussed. And you know a little bit of prerequisite, Python prerequisite is required. We will be doing Python for data science, but a little bit of Python saying like how to create, what are variables, what are classes, what are lists and dictionaries. So there are some of the basics which I might not be able to cover. They will be like a prerequisites. If you are familiar with any other programming language, it is good enough, so that you don't have to worry that I need to know Python only. It's not like that. If you are familiar with any other programming language or some programming constructs, you will be able to clearly do the course. And the topics which we'll be covering are, we will be covering math for data science, then we will be covering statistics, then we'll be covering Python for data science, then we will be doing machine learning, there will be doing natural language processing, deep learning, cloud computing, and DevOps. So this is the flow in which we'll be learning. So we'll start with the basics, very, very basics of mathematics. Then we will cover statistics. Then we will understand about Python for data science. Then we'll do machine learning, natural language processing, deep learning models. Then we'll do cloud computing. Especially in the cloud computing, I'll be concentrating on AWS. But if required, we'll also talk on Azure. I'm an Azure certified data scientist, so I'll also be helping you to crack any of the certifications and so on for for these providers. And we will be doing DevOps, where we will be covering the basics of DevOps, like how do we run Dockers, how do we containerize the applications using Dockers, usages of Git and deployments, and continuous integration, continuous deployment, and tips and tricks for that. All those things will be covered here. Right, so these are some of the basics, and the classes mostly will be from Monday 27 September. Monday classes happen from Monday till Friday, IST time zone. I am in India, so follow the IST time zone. Mostly the classes will be from 6 a.m. to 7 a.m. daily 1 hour class. So if you are in US, that would be from your Sunday night till Thursday night. That is how the timings will be. If you are in other part of the world, please use the geographical zone calendar to understand what is the time zone for you. But this will be 6 a.m. to 7 a.m. IST in the morning. Got it? So any questions on whatever we have discussed? I think we have spent a very good 1 hour dot 905. I started at 8:05. It's like a non-stop 1 hour. Any questions on what we discussed so far? Okay, so there's a one question. I heard mostly DS projects are in POC stage and in the startups. Do we have DS projects in large MNCs? Yes, yes. So DS data science projects were in POC stage couple of years back. Now they are matured. So small MNCs are still into experimentations and so on, but the bigger ones like bigger banks and all those companies have already matured. The retail companies have already matured, have already tried a few data science projects, and now they are in traction. Right? Is it too late to switch the career into data science? Nothing is late. So you just give, let me give my example. So, in 2011-12, that was the time when I ventured into big data. I was like a mainframe developer back then. Before that, I was doing legacy modernization projects and all those things. I wanted to venture into big data space. This was back in 2011-12, that time. And, I thought that, it's a new thing and other things and switching into a big database career. Now, big data, especially like Hadoop and other things, now Hadoop and other things is now obsolete, right? People are no longer using Hadoop. They are going to cloud systems and other things and so on. So what I'm seeing is the technology trend is changing very rapidly. So you might have learned something right now, but the trend is changing very rapidly. Maybe a combination of skills are coming as important things. So our thought of being late, maybe at this point it could be late, but because we are learning something very new right now, which is a combination of, so I would say that somebody who is learning data science should have this in mind. So I call it as a T structure. So data science is something which they have to concentrate on the depth, but they also have to concentrate on the breadth part. The breadth, which nobody talks, is the breadth about cloud and DevOps. And this is at the very nascent stage right now. People might learn about an algorithm, they might do a little bit of understanding of that. So that is where the current data scientists are. I do a lot of interviews for my company, and they might have a little understanding of data science, but they do not know like how do we deploy that into some production grade machines, how do we interact with other ecosystems like cloud and DevOps and other things. They have no clue. And I'm saying that for the coming 5 to 5 years, I'll not go for 10 years, but 5 years, this deadly combination is the key. You have to have a depth in the data science. You have to have a breadth, cloud, and DevOps. If you have this deadly combination, then it is certain that you're going to withstand for another 5 years. And maybe after 5 years, something else might come, right? Quantum computing or something like that. But for now, we are good with this combination. All right. I'm from a Unix storage backend. Will the training be covering full stack data science? Yeah, full stack data science is we are concentrating on, right? So as I was saying, this is the combination we will be concentrating, the data science with cloud and DevOps.
Sitaram, this is Srikanth actually. I'm Unix and storage admin. And also you answered the earlier question, like now I'm late in my career. So can I choose DS? Can I switch?
Yeah, you should be,
And what
as I
stage
said,
I can enter in the DS actually?
yeah, this is the area. So generally Unix DS admins or any system admins or database admins choose this area, primarily data storages, exploratory data analysis. Now, this is the entry point. I'm not saying that you can't enter into data science, but
Okay.
right choice or right way of entering is this. So concentrating on data engineering related jobs, which will be data engineering plus data science jobs, right? Those are the areas which you need to concentrate, and where we will be having both these worlds covered. But slowly the thought is to penetrate into the data science area, but
Mhm.
entry point will be from this area,
Okay. Thank you.
because you will be knowing like how to set up systems, how to run jobs, maybe like batch
Hello.
inference. This is also an area.
Hi, Sitaram garu. Sorry to interrupt you. Hello everyone, this is Lakshmi from Career. So important info from our end. The regular sessions will be starting from Monday IST onwards, that is 27 September, and the timings would be from 6 to 7 a.m. IST. I'll be sharing all the details along with today's demo recording. So you please do check your mail for other info, and you can contact us and the numbers whatever I have provided for more details. Thank you. You please
All right.
carry on, Sita. Thank you.
Yeah. Thank you. Thank you. So the information. So we starting the classes from Monday 6 a.m. to 7 a.m. IST. Right. So I think I've covered the Unix and storage admin part. So what do we need to do if I have zero knowledge on Python? At least I'm expecting some other knowledge in other programming language. Doesn't need to be Python, because we will be covering Python for data science. Whatever things required for Python for data science, how do we need to write codes and all those things I will be covering, right? But I'll not be talking about what is a list, what is a variable, and what is integer, floating point number, how do we store dictionaries and other things. I hope you are understanding. So that part, it will be it will be like very basics of the language. I'll not be talking about what is a class and how do we create a class and object oriented programming and all that stuff. So that will be covered as a Python course. You can also contact with Career IT. Many of my past students, what they have done is this Python will be like a 1 month course or so on. So they could do parallelly. The Python will give you a brief a refresher on these concepts. But the Python for data science, whatever I will be covering is like how to use the language Python for writing data science related codes, like how do we write algorithms, how do we invoke systems, how do we create maybe like a Flask based front end application which can invoke your model. All those things we'll be covering as a part of the course. But something whatever saying is, what is a variable, what is a string, and how do you do string operations, all these things, right? Those are basics which I might not be covering. Understood? I hope that is clear, everybody. If you are already familiar with some other language, or if you are already in the IT for few months or few years, you will be understanding it and you will get familiarized. And whenever I'm doing Python, I will take the account of all the students who are in the batch. So based on their understanding, I will either slow down, I'll go a little deep, or I will fast forward things. So if you already know familiar about some of the basic stuff, probably will be fast forwarding. But if you say like, okay, let us go deeper, we will understand more details, and that will be more interactive. So you have to ask questions, and based on the questions, we will be going in an interactive manner. So we hear other languages like R and SAS, those are dying right now. Python has a great advantage because it is having a generic purpose language. It is having great ecosystem. Lot of developers are Python enthusiasts. There are a lot of frameworks which are created using Python. Bigger companies are also backing up. For example, Google and Facebook have created their frameworks purely based on Python. So there is a lot of traction towards that language. We also have R and SAS and MATLAB and whatnot. There are other languages which we can use for doing these applications, but but those ones will have lesser penetration. So do we get environment for practice of the classes? We will be using cloud-based environment. So we'll be using Google Cloud for doing all our practice. So all you need is a Gmail ID. So if you have a Gmail ID, then you can easily use the cloud for running all our experiments and data practices and all those things. And you don't have to spend any money, right? You don't have to have a high-end machine for running all these data exercises. All we will be using is a cloud environment, and which is for free. So I'll be talking about, when we cover the Python part, I'll be talking like how to set up the environment and how do you do experiments and all that stuff. I'll be talking at that time. But for now, you don't have to set up any environment.
Hi, Sitaram. This is Deepak. So I
Yes.
come from a manual testing background, as well as right now I'm an UiPath, I mean RPA developer. So what will be means how much I can understand this data science? I mean, as I heard it, I mean there is a lot of coding in this. So how, in which way it will be useful for me? I mean, see which modules in the data science will be useful for me if I want to build a career as a data scientist.
Yeah, I think I already covered from a QA perspective that entry point will be called as an ML engineer. You have to search for jobs which are focusing on ML engineer, like building APIs, connections, testing on that. There is a good amount of work here, right? How do you deploy the models? Somebody else will be creating the code part of it. They might be junior data scientist or senior data scientist, and then they will be handing over the models to you for packaging and deployment, testing, interaction with front end people and all that stuff. So typical coordination kind of work will be there, but also we will have good amount of work. So people who have full stack experience and QA experience will start here. This is a good area to concentrate on, and then they will penetrate into it slowly, knowing all the coding and so on. And what we are seeing is we are seeing that there is an influx of cloud-based solutions which will have um, um, uh, over-the-counter kind of tools where we can just use automated tools for writing codes. So slowly it is tending towards that, where we might go to a no-code moment. But for now, we are still in the stage where we need to write code and so on. But maybe in few years from now, we might directly use a AWS solution which can directly build a model for us. And we need to know like how do we ingest the model, how to create an API for the model, how do we invoke it, how do we create a pipeline so that the model is automatically trained and delivering results and so on. So that will be a good skill to learn. For now, it is in a very nascent stage, and most of the QA folks, manual testers or automation testers, maybe especially like Selenium and some kind of load running testing, such kind of people will be uh, concentrating on this area.
I mean, what things that I should learn? I mean, if at all, as you said that all these things, I mean, I never worked on all these things. So what kind of technology should I learn? Means I should learn Docker or Jenkins. What I should learn? Can you please guide me on that?
Yeah, see, the course will cover everything.
Okay.
So it's like we need to know everything,
Mhm.
but focus should be on this area. Like if I'm searching for a job, right? Like imagine I do the course and I search for a job, the focus area should be this, where you will have more focus or more understanding on how do we do deployments and how do we do modeling and other things. So as the other person asked, a Unix kind of a person, focus will be here, not on deployment side, but on data manipulation, transformation, storages, and file operations. That is the focus. So focus area changes, but the course you need to have a full-fledged understanding, right? So we might not know, because even for this interview, they might be asking like, how do we deploy a model? How do we build an algorithm? Which algorithm to choose? All those things questions can arise, right? So it is expected that somebody who is doing this work is also having an understanding of other peripherals, so that they can be ingested into the project pretty quickly. So course would be concentrating on the entire end to end, but your focus should be on a specific area.
Okay. Yeah. Thank you.
Yeah. Hi, Sitaraman. This is Tejashvi. Currently, I'm pursuing my master's in Arizona State University. So, within 6 months, I would like to work as a data scientist. So, what, on which topics do I need to concentrate more? On which language, particularly?
What is your
In
master's on? Is it on computer
computer
science or
science. Yeah, exactly.
master's in data science? Okay, then I
Yeah.
think you can concentrate as a junior data scientist. There are roles like junior data scientist, data analyst, and so on, which is like entry level roles in US. Those are the roles you
Okay.
have to concentrate because you already have a master's in data science and computer sciences background. So you need to
Okay.
concentrate on the central area. You can also work on ML engineer jobs. So you have to concentrate on both of these, data science
Okay.
or junior data scientist or ML engineer. These are the roles.
Uh, do you have any suggestions like what courses if I take it will be useful for my future in my master's degree for the upcoming semesters
That is,
related to
you have to come, we talk case on case basis because I need to look at all the courses which are available, and based on that, I could suggest a few of them. So you're in the
okay.
third, right? So third sem or
No,
second sem?
no, I just started my first semester, so I
You
just
just
wanted
started.
to, yeah, I
Okay, I
just
think
started.
then see, because this is I can give assistance, but that could be, we can talk case on case basis which one to concentrate, like yeah,
Okay.
but the focus will be here. So you have to focus on your interns.
Yeah,
Arizona
exactly.
State University is a good university. You have very bright jobs from the Bay Area. So I think looking for jobs in Phoenix and around that area, you should be looking for internships. So, so for that you have to concentrate right from now.
Okay. Yeah, so I need to concentrate on machine learning, Python, these two.
Yes, yes.
So you'll be covering all these topics in this lectures, right? From starting Monday.
Yes, correct.
Yeah. Okay. Thank. Actually, I just joined a little late, so can we have this recording session to our mails? Can you forward that? Is
Yeah,
that
yeah. So the
possible?
organizers will be providing the recording, the entire recording of today's. They'll be providing you. And if you have any questions, further questions, you can reach out to me. But next week we'll go a little slow. We will start mathematics for data science and we'll applications of data science. So even if you have any further questions, we will be able to discuss. And this is general for
Yeah, hi,
everybody.
Sitaram.
Okay.
Yeah,
Hi, Sitaram. Yeah,
yeah.
good morning. Data science is a development or administrator.
It is a development role. Administration roles,
Okay,
what is happening? They are slowly getting into an automated manner, right? Previously, people used to have administrator roles, but they are now slowly getting into an automated manner where we can deploy DevOps-based things, which can automatically create services and so on. Even if certain things are going down, there are automated services which can bring them up. So, so automation is being playing a major role in that. So this is area is into development.
okay. It involves the streaming also, data science, streaming, data streaming.
Yes, it will also involve streaming. Yes.
Okay, clusters.
Yeah, creation of clusters, it depends. You might use cloud-based services where we can use um, distributed storages
Okay,
like S3 and other things. But for running your models, you can run distributed clusters. So I'll be talking about model-based clustering. Storage-based clustering, now we are slowly going towards cloud storages like S3 or Azure Blob storages and so on.
okay. Mm. Uh, data science, how to integration with machine learning. I have about Hadoop, Hadoop integration with Kafka and Cassandra also. I know the scenario, but machine learning, how to integration data science with machine learning.
Generally, if the company is completely like a data engineering shop, which is already having Hadoop and all, they will be using Spark machine learning for that. But many of them are using cloud-based ML, where they will be running Python-related jobs, which will be doing much better than Spark-based machine learning. So there are integration steps, like once the data comes into a storage, from there we will be building a pipeline and we will be running ML jobs, which can be run on a batch mode. Generally for a Kafka-based storages or for Hadoop-based storages, we will be running batch-based inferences, and which will run some jobs and give outputs to the same uh, cloud storages. That's how it works.
Okay.
Hi Sitaram garu, good morning. This is Chanakya from Hyderabad.
Hi, Chanakya.
Yeah, how are you, sir? It was nice talking with you.
I'm doing very good. Hope the same with you.
I have one small question regarding for this data science course. Actually, I'm a commerce background student and I don't have knowledge of this thing of Python and other languages. And presently, I'm working in DHFL. It's a home loans company. I'm working as an associate manager.
Okay.
So is this a data science course will be it's a added advantage for me for my future?
So you want to completely shift from commerce to a software kind of a thing? Is
Yeah,
that the thought?
exactly. But exactly.
Okay.
But I'm looking at some big change also for in my future. So that's why one of my friend referred this course and given this link. I have joined a little bit late today morning because of this link not received to me. So
Okay.
can you guide me in this?
Yeah, because this will be case on case, Chanakya garu. So I can definitely guide you. So we will also offer assistance with respect to resume preparation and job searching and other kind of things. And even you get after the job, the after job support would also be provided. Support in
Mm-hmm.
sense, we will not be doing the entire work, but if you have any questions, doubts, and such kind of things, we will be helping our past students also. So, but for
Okay.
individual cases, right, because this is a complete class, any question related to the class, we will be covering. But for your
Okay.
case, right, I will give a simple this thing that switching from one area to other area is it's not straightforward. It is doable, but it will take certain challenges. You need to have a right entry point if you have some connections or network and where you want to get into a specific area. First thing is you have to get into that area first, and then we can expand on that. So entry points for data science will be something like data analyst, junior data scientist. These are some of the roles which are entry points. But if you already have a good amount of experience, you can then become like a lead data scientist or a data science lead, which will be leading multiple junior people and getting work done from them. So such kind of roles are also there in a lot of startups and product companies and service companies. But yeah,
Mm-hmm.
for you, it will be we have to do case on case basis, like what type of job roles are there in Hyderabad, or maybe you are okay to relocate to say Bangalore or Noida, Pune. So what type of roles are available and which companies are opting, and so we have to do case on case basis. It's a mostly one on one kind of a thing, right? So that is my suggestion.
Is the data sciences works are going in Hyderabad? I mean, such companies are there.
Yeah, a lot of companies are there, Hyderabad. So what I would recommend is you I'm sorry. What I would recommend is you do create a portal on Naukri, create a profile on Naukri, and try to search like different job opportunities. There are a lot of
Okay.
companies in Hyderabad who are looking for data scientists both at junior levels and senior levels. There are a lot of
Mm-hmm.
startups also, Hyderabad, Bangalore, Noida, and other areas which are looking for
Okay.
jobs.
Oh,
Jobs are there, only
okay.
just to talk. Okay,
Okay, Sitaram garu. I will continue from Monday onwards.
all right. Thank you.
Yeah, thank you.
Any
Thank you.
other questions? Generally, to the topic, whatever we discussed, any questions related to this? This is clear, right? For most of the people.
Hi, Sitaram, this is Jaychandra. So I have a doubt, like when you say Google Cloud, so you'll be uh, using TensorFlow, uh, scikit-learn, and writing the code from the scratch, or you'll be using the auto ML option to build a model?
We will be using both, but mostly our concentration will be writing the code from scratch or building code-based applications. ML ops is the maybe future. Maybe in the future we will have auto ML kind of options. But for now, we need to have a good understanding for getting into the jobs, right? Because they will be asking questions, interviews on how algorithms works, which one to choose, when to use, what types of transformations to be done. So for answering all these questions, we might have to have good understanding on the basics. So we will be doing most of our work will be on writing code from the scratch, so that we know like how different things are done from bottom up approach. Google Cloud, what I'm saying is we will be using something called as Google Colab, which is one of the
Yeah, I'm aware.
one you are aware of it, right? So that
Yes.
is what we will be doing, which is an environment for running this code. So I'm not, when I'm saying Google Cloud, we will not be running on GCP platform. We are using something called as a Colab.
Okay.
Wow.
Okay.
I'll be talking about the setup. If you are already aware, very good. But for people who do not know, like what environment to run, should I have better laptop? Should I buy something? People ask these questions in the first class. So I say like, don't worry about that. We will be using a very free service, which will have all the things which are required for the project. It will create an environment for us, and we can practice 24/7. So we don't have to have any additional things purchasing for this course, right? So that is
Yes.
the point.
Okay. Thank you. Thank you.
And for again, a point for everybody that these questions can be some questions can be very basic, some questions can be very advanced, because we have mixed group of people. But my my expertise is in to bring everybody into the same page. Okay, after we continue few sessions, everybody will be in the same page. Mostly we'll try to bring that mix and match. So don't worry that if you are listening some words that you have never heard, that what is this, is it having so much of depth and so on. Don't worry about that. What you just concentrate is whatever we are learning in the class, are you following or not? If you're not following, please put a question on the chat, or maybe wait for the end of the class to ask the question, so that you will be clarified. And even if you don't want to ask question, or you want to catch up later, I will be having maybe a one-on-one discussion with you guys for clarifying any doubts, personal doubts, and so on. So such kind of assistance is also provided. So don't get disheartened in the initial classes. I see that this kind of thing that other people know a lot of things, I don't know anything. So such kind of thing should not be there. And I have great expertise in bringing everybody on the same page, so that by after the weeks go on, we will be settled, almost like everybody will have the similar kind of understanding of what we are going to do, right? So that belief or trust should be there. And I'm very certain that I've done this for many students in the past, and we can also do. And teaching is my passion, and I do it with a great passion. And I also I'm doing this trainings for almost like 7 years right now. So I have dealt with many students in the past, so I know like how people think and behave and other things, right? So we all together can go and achieve this goal. That is my urge. All right, any other questions, or else we can close? Apologize, I got a little delayed. We took a little more time, but I hope that answered many of your questions or doubts regarding the session, right? If you have any questions, we will discuss, or else we will drop off. For your students, it will be might be very late. So if you don't have any questions, you can drop off. I hope you like the session and the way of delivery. And if you have any questions, you can join the Monday's class, and we will be doing other topics, and slowly we will continue through the course. All right. Thank you very much. Okay, you can drop off. Thank you. If you have any questions, you can put it in the chat, but or else you can drop off. Thank you very much. Have a nice day.